Is this Willy Willy a mini tornado? Not quite. It's a dust devil. These slender, spiraling columns of air filled with dust and sand are sometimes mistaken for mini tornadoes. But they are actually a fundamentally different phenomena, driven not by storms or severe weather, but by surface heating and the laws of fluid dynamics. A dust devil begins with sunlight. On a clear day, the ground surface absorbs solar radiation and becomes significantly warmer than the air above it. This creates a strong temperature gradient in the lowest layer of the atmosphere, making it unstable. The air immediately above the surface becomes lighter and more buoyant, and parcels of this warm air begin to rise through the cooler layers above. This upward motion is known as convection, and it's the same process that produces cumulus clouds, except in the case of dust devils, there's no moisture to form visible vapor. So, the rising air leaves behind a partial vacuum near the ground, drawing in air from the sides to replace it. If that inflowing air possesses even a slight rotational motion, caused, for example, by irregularities in the terrain or small variations in wind direction, then the motion can intensify as it converges towards the center of the updraft. As the radius of the rotating air shrinks, its rotational speed increases, a bit like a figure skater spinning faster by pulling in their arms. Once the vortex forms, the strong upward motion at its core begins to lift dust and loose particles from the surface, making the otherwise invisible column of air suddenly visible. A fully developed dust devil can reach a few meters across and extend hundreds of meters into the air, but the pressure difference within the vortex is small, so dust devils rarely cause significant damage. They are usually short-lived, lasting only a few seconds to several minutes before dissipating. But what makes dust devils really interesting is that they reveal fundamental truths about atmospheric physics. They are spontaneous, self-organizing systems that arise from nothing more than heat, instability, and a touch of asymmetry in the air.